In a population under Hardy-Weinberg equilibrium, 16% of individuals show the recessive phenotype for a trait controlled by a single autosomal gene. What percentage of the population are heterozygous carriers? Stay with me here because we must approach this systematically. What is the very first thing we do? Remember our checklist rule. Always find Q first. Let's break down the information the question gives us. It says 16% of the individuals show the recessive phenotype. In population genetics, individuals who show the recessive phenotype must possess the homozygous recessive genotype. Mathematically, the frequency of this genotype is represented as Q squared. So write this down right now. Q squared equals 16% equals 0.16. Here's the exact exam trap that trips to thousands of students. Many will immediately plug 0.16 into the equation as Q. Do not do that. If you use 0.16 as Q, your entire calculation will fall apart. We must find the single allele frequency Q by taking the square root of Q squared. Therefore, Q equals square root of 0.16, that is 0.4. Now that we have the recessive allele frequency Q, we can easily find the dominant allele frequency P. Remember our foundational equation from the first principle that P plus Q equal 1. Rearranging this gives us P equals 1 minus Q. Plugging in our value, we will find P is 0.6. The question asks for the percentage of the population that are heterozygous carriers. Look back at your Hardy-Weinberg expansion formula. P squared plus 2PQ plus Q squared equals 1. The term that represents the heterozygous frequency is 2PQ. Let's calculate the value step by step. 2 times 0.6 times 0.4. Multiplying this out gives us 0.48. Converting this decimal back into percentage gives us exactly 48%. Looking at our options, answer C is 48%, which perfectly matches our calculation.